Hi everyone and welcome to this video on multiplying and dividing expressions, part of a Year 7 algebra course. Now, if you're not in Year 7, don't worry about it. Doesn't mean you cannot watch. Just dive into this stuff. Algebra is freaking awesome, but as I say all the time, it is a big fat trick. Now, if you're watching on YouTube, it's really good to see you. Do me a favor if you can. Can you click the little doohickey in the corner that'll subscribe you to my channel? Subscribers mean all the difference to me. They should let me know that you are watching. If you are over on maffsguru.com, there is also that doohickey, but wow, have you got way more things that you can do. Now, if you haven't already, head on over to maffsguru.com and look at lesson notes and time code and all those exciting things. Now, multiplying and dividing expressions, by the end of this lesson, as you can see above, I want you to be able to do all sorts of exciting things. Write multiplication and division questions. Remember that multiplication is commutative, easy for you to say. Numbers should be written first, perennials, and all that exciting stuff. And yes, recapping. It's fairly fast-paced, isn't it? Because we're trying to get all of this exciting language and stuff over and done with so we can actually practice the real algebra, because algebra is going to be used for the rest of your maths career. It's going to come up in absolutely everything. And the good thing is you can do this. You see past the tips and the tricks and all that smoke and mirrors and all that rubbish that mathematicians throw there to make it complicated for you, and you will get through this. Now, let's show some love, as I already say. Now, I don't know about you, but I love my mum and dad. I love a lot of people. And I like sending cards. Now, over here in Australia, sending cards doesn't seem to be a very big thing, but in the UK, it is massive. And so each year I'll send my mum a card, I'll send my dad a card, and I'll write them lots of lovely messages. And at the very bottom of each, I will write, "Love you." And I'll write Darren, because it'd be really weird if I wrote Maths Guru. And then I put kiss, 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 kiss. Now, they think I'm sending them love, but what they don't know is that it's a bit of a maths joke. Because what do you notice these things look like? Multiplication signs. Yes, so I am saying kissy kisses, which is what I use all the time on cards, are exactly the same as, yes indeed, multiplication signs. So between numbers and letters and numbers and numbers and all these exciting things, I know that where a number and a letter is stuck together, they are actually kissing. Too much information if we go too much further, but I need that really important point to be thought through this video. Okay? Once you see past that tip and that little trick, it is awesome. So for example, if I have 3A, now yes, we can think of that as 3 apples or 3 lots of an apple, but I think of that as the 3 and the A are kissing. Oh yes, they are kissing. Now I can put the kissy kissy in and I can take the kissy kissy out. Now when I do that, that's the difference between writing it in expanded form and writing it in more simplified form. So what about 4AB? Well, that's just 4. Kissy kissy A, kissy kissy B. And I'm going to say that all the way through to year 12. Believe it or not, I promise you, it doesn't ever get old. I'm getting older, but that kissy kissy stuff doesn't get older. So, big trick for this one is write the kissy kissy. Now, what about fractions? Have you already switched off? Don't switch off if you hear the word fractions. Fractions, I think, have got a bit of a bum rap. It's not a great thing, and I think, sadly, lower down in the school, sometimes fractions isn't taught as well as it could do, but we can break that. We can sort it out in this now. The point you need to realize is that when we cancel down fractions, it is really important. Now, we do it with numbers, don't we? So if I scroll up a little bit, let's see what happens. If I gave you 2 on 4 as a fraction, I'm pretty sure everyone in this video watching world is going, well, that's the same as a half. Absolutely. Why is it the same as a half? Because we know that the number on the top and the number on the bottom is divided or divisible by 2. Both the top and the bottom can be divided by the same thing, or their highest common factor. So I know that 2's divide into 2, whoops. We know that 2's divide into 2 once, and we know that 2's divide into 4 twice, and so we know that's the same as a half. Not a particularly complicated example, no? Marvellous. What about 6 on 9 then? What's the highest common factor of 6 and 9? Or what number divides into 6 and what number divides into 9? Again, I know that they are both divisible by 3. Knowing that, I can say, well, how many 3's are in 6? There are 2. And how many 3's in 9? There are 3. And so, yes, I get 2/3 as my lowest fraction. Now again, lots of kids say to me, well, there's lots of ways of doing this. There is indeed. So if I had, for example, 50 over 100, it might not always be obvious what the highest common factor is. And so I always say to myself, well, if the top number is an even number and the bottom number is an even number, I can halve it, because halving things, dividing by 2, is the easiest. So how many 2's go in 50? 25. How many 2's go into 100, or what's half of 100? It is 50, and I'm finished, yes? Because I now can see that 25 and 50 are both divisible by 5. How did I know that? Well, number facts. If a number ends in a 5 or a 0, we know that it's divisible by 5. Absolutely awesome. So how many 5's are in 25? There are 5. How many 5's in 50? There are in fact 10. And so we have 5 on 10. Is that the end? Nope. Because once again, we can cancel these down, because I know that 5's into 5 go once and 5's into 10 go twice. And yes, we have a half. Now you're probably sitting at that going, well, that was obvious. Why are you telling me this stuff? Aha! Well, he says, because we're now going to go and ramp it up a little bit. So here's a question to you. What is 1 divided by 1? It's 1, yeah. What is 2 divided by 2? It is also 1, yeah. What about 10 divided by 10? Oh yeah, it's still 1. Because we know that anything that is on the top and the bottom that is the same, anything that divides by itself is always going to be 1. And because the top number and the bottom number are exactly the same, we can say that 10 divided by 10 is 1, and there we go. So what about 50 divided by 50? Yes, it is still 1, because what I'm doing is saying on 50 is into there go once, and 50 is into there goes once, and we know that 1 divided by 1 is 1. So here's the question. What is A divided by A? Now, your brain shouldn't have fritzed, because you should be able to try and say, well, hold on, anything divided by itself is 1. And absolutely, so A's into A goes once, A's into A goes once, and 1 divided by 1 is in fact 1. What about X divided by X then? Again, also 1. Now you're going to say, but hold on, does X divide by A? No, no, no. We're looking for the thing on the top and the thing on the bottom to be the same, and then we divide by that. So we say, well, X's into X's go once, and X's into X's go once, and I get 1. And, oh, I don't know, let's just do one more. Let's do P divided by P, and I'm going to tell you that's also equal to 1. Really, really important for what we're about to move into. Now, cancelling down is nothing more than taking the common number or letter, we've said, from the top and cancelling it from the bottom of the fraction if they are the same. Okay, this means we can do the same idea in algebra. So, I've done some examples up there. Let's ramp it up a little bit and make it a little bit more complicated. I have now, let's say I've got A, B divided by A. So what do we have here? Well, between a number and a letter, or a letter and a letter, there is a kissy kissy. So I'm going to write that as A, kissy kissy B on A. Question I'm going to ask you is this. Are all the tops of my fractions multiplied together? They are. Are all the bottoms of my fractions multiplied together? They are. Well, now I can do this cancelling from my fractions. So the question is, do you see a letter on the top and a letter on the bottom that is the same? Yeah, A. So what I now say is, how many A's go into A once? How many A's go into A once? And there we go, life is good. Now, if I look at this and simplify it, I've got 1 times B on the top. So let's write it out long ways now first. So that's now become 1 times B on 1. Well, 1 times anything is the thing. So 1 times B is actually B. And divide that by 1. And we should know that anything divided by 1 is also itself. So that simplifies down to just B. All right, so let's do another example. B, C on, let's say B then. So let me ask myself the question, are all the tops multiplied together? They are. And the bottoms all multiplied together? Well, yeah, it's just got one letter, so it must be. And so I ask myself the question, is there a letter on the top and a letter on the bottom that is the same? I should go. And so I say B's into B go once and B's into B go once. And so that becomes 1 times C divided by 1, which just becomes C. So I'm going to skip a bit of a step there, because 1 times anything is the thing, and anything divided by 1 is the thing. And so there we go. Right, all right, all right. I think we're getting a little bit more excitable now. Let's do a little harder example. Let's do x, y, z divided by, let's say, x and b. Ooh, right, so let's follow the rules. First things first. X, kissy, kissy, y, kissy, kissy, z divided by x, kissy, kissy, b. All right. Ask myself the question, are they all times on the top? Yep. Are they all times on the bottom? Yep. So now I can do my, is there a letter on the top and a letter on the bottom that's the same? Well, there is. There's an x there. So x is into x go once, and x is into x go once there. I don't see any other letter on the top or the bottom that is the same. I've got y times z and b on the bottom. None of those are the same. So I end up with 1 kissy, kissy, y, kissy, kissy, z divided by b. Well, 1 times anything gives me what it is. So that becomes y times z on b. Or if I'm going to do this, y, z on b to write it out. Because generally we don't leave those kissy kisses in. We slop it back in there. I am loving this algebra stuff altogether. Let's do one more example. Let's do a, b, c, d, e divided by c, d, f, and g. Now you already may be a step ahead of me here. That's not a problem. So, a, kissy, kissy, b, kissy, kissy, c, kissy, kissy, d, kissy, kissy, e divided by c, kissy, kissy, d, kissy, kissy, f, kissy, kissy, g. Right, are all the tops multiplied? Yep. Are all the bottoms multiplied? Yes, they certainly are. And so I can do my little cutting down. So I've got an A on the top and the bottom? Nope. Have I got a B on the top and the bottom? Nope. Have I got a C on the top and the bottom? I sure do. So C goes into there once, and C goes into there once. A D goes into there once, and a D goes into there once. And because I have an E on the top but not on the bottom, and an F and a G on the bottom but not on the top, then I now leave that as A, kissy, kissy, B, kissy, kissy, 1, kissy, kissy, 1, divided by 1, kissy, kissy, 1, kissy, kissy, F, kissy, kissy, G. Now, anywhere I see 1 times anything, it effectively just goes. I can ignore it. So that leaves me as A times B on the top and F times G on the bottom, which if we write it simpler, becomes AB on FG. Now, if you've got that, you are 2/3 of the way to mathematical awesomeness. Totally, totally awesome. But as usual, there is a spanner in the works. Now, what do you notice about this question? Well, I've got 3a plus ab divided by 4a. Now, the first rule I say is put in all the kissy kisses, which is equal to 3 kissy kissy a plus a kissy kissy b divided by 4. Oh, 4, don't forget the kissy. You've just said that, masculine kissy kissy a. Then I say to myself, are all the tops times together? No. Why not? Because I've got this plus sign in. Now, when I've got a plus or a minus there, I have to be very, very careful. Because when I cancel letters or when I cross them through, I have to make sure that there is a letter in every single term to cancel. So if we go back to this, I suppose the question I now ask is, how many terms did I have in that fraction there? I had 1 term on the top and 1 term on the bottom. Anything connected by times is a term. How many terms did I have top or bottom here? 1 on top, 1 on bottom, and 1 there and 1 there. Same thing, but this is now slightly different. So you just have to remember how to do this slightly different. So I've got 2 terms on the top that can't be simplified. I can't add 3 apples and an apple banana divided by 4 apples. But what do you notice is in every single term, they all have the letter A. Now that's great because in that situation then, if every single term has the letter, I can do the cancelling out thing. But this is what I do. So I say an A becomes a 1 there, and the A becomes a 1 there, and the A becomes a 1 there. So an A from every single term cancels out. Now, why that is, just accept it for the moment. A little bit later on in the course, we'll show you this thing called factorizing, but it's a little bit beyond this now. So what does that leave me with? 3 times 1 plus 1 times B over 4 times 1. Well, we know what 3 times 1 is. It's 3. We know what 1 times B is. It's B. And we know that 4 times 1 is 4. And ladies and gentlemen, that is my final answer. Mais oui, très bien. All right, so what about this example now then? Let's have a look. So the rules are, let's put the kissy kissies in, equals 2 kissy kissy x kissy kissy y plus 5 kissy kissy d kissy kissy x, well, it wasn't easy for me to say, over 7 kissy kissy d. Right, is there times is across all of my terms? Nope, there isn't, because I have a plus. So now I have to see, is there a letter in every single term that is the same? Now what do I mean by every single term? Remember, this here is a term, that's a term, and that's a term as well. So do they all share a common letter? Well, if we look at the bottom, what do I notice? Well, the bottom's got a D, that term's got a D in it, but this term here does not have a D. Oh, shucks. So that means, ladies and gentlemen, because the terms don't actually have a common letter, it stays exactly as it is, in which case I can't actually write that any simpler than it is. And so it's a bit of a trick. Right, okay, let's get back to some love, and the questions I'm about to do come from the Cambridge Essential Textbook Series. Thank you very much, Cambridge, for allowing me the time and opportunity to use your first class examples. Love, love, love. So here we go. Let's just throw all of the learning we've done today. Question number 1. All right, 4 kissy kissy A, kissy kissy B, kissy kissy C without the multiplication signs. So we're going to turn it from expanded form into simplified form. So we know that becomes 4A, B, C. And they say that this algebra stuff is hard. Ha! What about simplify 4A times 2B times 3C? Well, the first thing I'm going to do here is I'm going to write all the kissy kisses in 4 kissy kissy A, kissy kissy 2, kissy kissy B, kissy kissy 3, kissy kissy C. Now, there is a word we use in maths called cumulative. Anyway, it just means that 1 times 2 times 3 is the same as 3 times 2 times 1, which is the same as 1 times 3 times 2. And so it goes on. What we say there is that where all the kisses are, where all the terms are kissing together, we can move the order around without changing the final answer of my question. So I now know that can become 2 kissy kissy 3 kissy kissy 4. Why? We normally put the numbers at the beginning and then we write the letters in alphabetical order. Now, is there anything here I can simplify? I would hope so. Yes, I know what 3 times 2 times 4 is, or 2 times 3 times 4 is. 2 times 3 is 6. 6 times 4 is 24. So that becomes 24 kissy kissy A, kissy kissy B, kissy kissy C. Can I simplify that anymore? Nope. There we go then. So that just becomes 24 A, B, C. And what I mean is, when I say can I simplify that anymore, what I mean is I can take out the timeses, but there's no numbers I can multiply together, or in fact letters. Now, yeah, I just said letters can multiply together. And here is an example of where we start coming into floaty numbers. Now, for those of you who have watched my previous videos, we have something called BIDMAS, where for me, the I is the floaty number. All right? And floaty numbers are brilliant because they tell me that letters are multiplied by themselves or numbers. So for example, 2 with a little floaty 2 is the same as 2 times 2, which is the same as 4. 3 with a little floaty 2 does not mean 3 times 2. It means 3 times 3, which is 9. If I had 4 with a floaty 3, that would be the same as 4 times 4 times 4. So the floaty 3 is telling us how many times to multiply that big number by itself. And 4 times 4 is 16, times by 4 is 64. So we're going to use that idea now to say, well, we can simplify 3W times 4W. Right, well, we know that can become 3 kissy kissy W, kissy kissy 4 kissy kissy W, which is 3 times 4 times W times W. And we know that 3 times 4 is given by 12. Yup, 12. Thank you very much. And what about this W times W? Well, now I'm just going to use the indices backwards because we know that W times W is the same as W with a floaty 2. It's a shortcut, so save us writing out all these W times W times W times W, blah, 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 blah. Okay, so there we go. We are powering through. We're almost at the end of this video. So write the following without a division sign. Well, here we go. We've got a divide sign here, a divide by 5. And this question is a big fat trick, because what they want you to say is we know that 1 divided by 2 can be expressed as 1 on 2. Same. So if I've got 3x plus 1 in brackets divided by 5, that can be expressed as 3x plus 1 all divided by 5. And we can leave that top in brackets. Doesn't actually matter. That was easy. And we're going to use our funky maths from earlier. We have 8ab divided by 12b. Now, interestingly, there's a bit of a trick here. All right, and the thing is, you guys will get so ingrained with doing the algebra, you'll forget the numbers. And what do I mean by that? Well, remember that 8 and 12 can also be cancelled down. Don't forget that. So, first things first, 8 kissy kissy A, kissy kissy B, divided by 12 kissy kissy B. Is all the tops multiplied together? Yup. Are all the bottoms multiplied together? Yup. Is there a common term on the top and the bottom? There is, or a common letter. B cancels with B, so B divided by B is 1. And then I have to say that 8 and 12 can be divided by 2, which becomes 4 and 6. And then we notice again that both of those can be divided by 2 again, which gives me 2 and 3. And so my simplified is 2 times A times 1 divided by 3 times 1. Well, 2 times A times 1 is just 2A on 3. And there we go. Now, ladies and gentlemen, that is just literally scratching the surface of this type of stuff. I am so glad that you've made it to the end of this video, because we are pretty much done with multiplying and dividing expressions. Thanks so much for taking the time and watching. It's really good to see you. If you haven't already done so, please subscribe to my YouTube channel. It would be greatly appreciated if you could, and let your mates know. Otherwise, I'll be back in just a few minutes, actually, because I've got a whole range of videos lined up to record. Have a good day. I'll look forward to seeing you in the next video. Take care.